Hello, geometry students. It's Mr. Lehman again. This week, our video lessons are going to be focusing on circles. We've already done some things with circles in previous lessons. We talked about the center, the diameter, and the radius. We talked about finding circumference of a circle, which is the distance around the circle. We talked about finding the area of the circle. So in this unit, we're going to be focusing on the interior and exterior of a circle and different things that we see and relationships that are formed. So when we sketch a circle, so here's my horrible circle that I freehanded. We know that the center of the circle here, if I sketch a line that goes from the center of the circle to the outside, or to the circle itself. This is referred to as the radius. We have our center. And then if I sketch another line that goes from one point on the circle through the center to another point on the circle, that's referred to as the diameter. Up until this point in math classes, this is what you have primarily worked with a circle. And then the distance around the circle is referred to as the circumference. So this week, we're going to be focusing on different segments that are inside the circle or potentially outside the circle besides the diameter and the radius. So again, I'm going to draw another circle, another not so great circle, but again, it gets the point across, and I don't have a compass at home. So with a circle, any segment that has endpoints on the circle itself, so this segment, we'll call this AB. This segment is referred to as a chord. So again, a chord is a segment with endpoints on the circle. Any segment. So technically a diameter is considered a chord because it has endpoints on the circle itself. Now, with that said, the next type of line that we run into is what's called a secant. So secant. So a secant, we'll call this line L, is a line that intersects the circle at 2 points. So again, a secant is a line that intersects the circle at 2 points. Okay. Last but not least, the third type of line that we run into is what's called a tangent line. So a tangent line is a line that only intersects the circle at 1 point. And we'll call this point C. So this line here is what we call a tangent line. So again, if something is tangent, it's a line that intersects the circle at 1 point. And this 1 point is in the exterior, or the line itself is in the exterior. So notice that a tangent line is never in the circle. If it crosses into the circle, it's now known as a secant, not a tangent. So these are the three main segments that we'll see throughout when dealing with circles. Okay. Now, just a few things to notice about a tangent. So again, I sketched another bad circle here. So here I have my point, and I have my line that's tangent. So we'll call this point C. In the circle, I'm going to put the center of the circle in. We're going to call this center O, and we're going to sketch the radius. So one thing that you'll notice here is that the radius of a circle is perpendicular to the tangent. So again, the radius is perpendicular to the tangent. And for those of you that haven't seen this symbol for a while or don't remember what it looks like, remember that this means perpendicular to. We talked a lot about perpendicular. Remember, perpendicular means that it intersects and forms a right angle. So here we can say that the radius of a circle is perpendicular to the tangent of the circle. Okay, so another idea that comes up about tangents is if I have a circle, and let's say I have two lines that form tangents, because a circle can have many tangents, okay? So here's my two tangent lines. We'll call this point B, we'll call this point C, and we'll call this point A. So the idea here basically is that if two tangents intersect at the same exterior point, then the segments are congruent. So again, if two tangents, it would help if I could spell T-A-N-G-E-N-T-S. So two tangents intersect at the same exterior point, then the segments are congruent. So I've got two tangents, they intersect at the same exterior point, so therefore we can say that AB and AC are congruent. So AC and AB are congruent. Now, where could we see this applied? Well, for example, they might tell us that AB is equal to 3y, and they'll tell us that AC is equal to 5y minus 28. And they'll say, solve for y and find, so they'll say two directions. One will say solve for y and find, let's do AC. Find the length of AC. Okay. Well, because these are two tangents and they intersect the same exterior point, we can say that these two are congruent. We've already established that. So if I say that segment AB is congruent to segment AC, remember that if two segments are congruent, then we know that their distances, their lengths, are equal. So we can say that AB is equal to AC. Okay. So we know that AB is equal to 3y. We get that from the picture. We know that AC is 5y minus 28. We get that from the picture. And we solve for y. So we solve this equation. I'm going to subtract 5y from both sides. We get negative 2y is equal to negative 28. Divide both sides by negative 2. And we get y is equal to 14. Wonderful. So we've done the first part. Check. Now we've got to do the second part. So now we have to find AC. So we know from here that AC is equal to 5y minus 28. So we set that up. We know that y is equal to 14. So we substitute that in. So 5 times 14 minus we use order of operations. So 5 times 14 is 70, and we do 70 minus 20 to get 42. So therefore, the length of AC is 42. Check. We have done the second part. All right, great. So again, just to recap, circles have three basic types of lines here besides diameter and radius. We have a chord, we have a secant, and we have a tangent. All right. If you have any questions, feel free to email Mr. Lehman or Mr. Ard, or email us to set up a Google Meet or catch us during office hours. And in the next video, we're going to be talking about arcs and chords in particular. Talk to you soon.